For those of you who don't know me, my name is Milen Dyankov. I work as a senior consultant at Liferay, and I'll be talking to you today twice. Don't ask me why. They put me twice on stage, like no one else do. That's probably because of my French accent. I don't know. Anyway, the first talk is OSGi fundamentals. And the second one will be more about Liferay than about OSGi. So I'm really curious what would go wrong today, as today seems to be one of those days that you never know what's going to happen. So to make use of what I learned in France several weeks ago when we were doing the partner bootcamp, this is la partie blabla. And then the second talk would be more of a demo. So I hope nothing's going to go wrong here. Because I'm going to be only showing you nice pictures. Not of Paris, but next talk will be pictures from Paris. So. Okay, let's do a little quiz first. Who of you are developers, like writing Java code? Let's say that's 80-90%. So how many of you can write a hello world OSGi way? Okay. Now, that's the right audience for this talk. So, because I was thinking about how to do OSGi fundamentals and how much of a code and how much of actually programming I need to show you. The one problem with that is that when you only have like 45 minutes and you boost like, I don't know, hundreds of slides with code samples, it's just way too much information to process. So I would like to take a little bit different approach and explain to you OSGi conceptually, like why we choose OSGi and what is OSGi all about. So then next time you start dealing with OSGi, which essentially you will if you start dealing with Liferay, then you understand the concepts and the basic and the fundamentals. So when we talk about OSGi, basically we talk about modularity. And it's the main reason for OSGi to exist is to provide you a ground for modularity. So and that's what makes it not pretty, right? If you introduce the new JavaScript framework with all the fancy effects, like everyone goes, wow. Introduce the new whatever Spring something, they go wow. And OSGi is more about those tiny little things in the background that actually makes things work, that actually makes your developer experience, or not exactly your experience maybe, but your applications better, without actually having something to show off, without actually showing something that everyone goes like, wow. And so it's fairly overlooked tool. So thinking of OSGi, think about modularity, and this is what it is all about. Now, the question is, what is modularity? And there was a famous saying for those of you who are familiar with Alice in Wonderland will probably recognize this, which is when I use a word, it means just what I choose it to mean. And this is basically how the word modularity has been used over the years. Like, yeah, if you put things into different jar files, then you already have modularity, right? If you load stuff from different places, then you already have modularity. So basically, everyone defines modularity the way they wish and the way that is comfortable and works for them. There's nothing bad with that. The question is, can we standardize or can we agree on what actually modularity means? So, several years ago, and I hope this works. Okay, it works. Several years ago, Dr. Graham Charters introduced at the OSGi community event a thing called modularity maturity model. Those of you who are familiar with capability maturity model will probably see a lot of similarities in here. So basically, he defines hey, I spoiled the surprise. This is supposed to be like this. He defines 6 levels. And the 6 levels of modularity are like hook modules, modularity, loose coupling, devolution, and dynamism. And if you want to actually get a deeper understanding, you need to go read the paper. But basically, it says that at the first level, you have no modularity. This is your traditional Java, put everything together and make it work. Then if you want to go modules, you are decoupling yourself from the artifacts. So basically, you give your artifacts an identity, and that's what you rely upon. You rely upon identities, not artifacts. Then you want to move one step up, and you want to decouple yourself from identities as well, right? And this is when you're starting to get what is considered like a real modularity. But then you are tied to implementations. So it's still kind of tight coupled. So if you manage to go beyond that point, to decouple yourself from implementations, then you go to the devolution, where you kind of depend on ownership and then time. And I'll show you in deeper examples what exactly this means. So this model kind of works for OSGi. Well, then he actually defined level 7, which is known as Peter Kriens. And it's only available if you are Peter Kriens. And for those of you who don't know who Peter Kriens is, he's one of the people, like one of the most important figures behind OSGi, the person who actually made a lot of those things work. And as he describes himself, like he eats and breathes modularity for the last whatever years. So Peter Kriens took over that model in a book known as Java Application Architecture. Actually, he didn't write the book, he wrote the foreword for the book. And he, in there, says that if he was to define a modularity maturity model, he would redefine it in a little bit different way. Basically, he would use ad hoc, he would use unmanaged, managed, proper isolation, minimize couplings, and then service-oriented architecture, which is more or less agreeing with the original definition, just kind of shifting it in a little bit different direction. So when I was preparing this talk, I was like, which one I should use? And I said, well, what the hell, I'll make my own. So here is a buzzword-compliant modularity maturity model, because you all love buzzwords, right? I mean, come on, microservices, Docker, right? That's how we do software these days, buzzwords. Okay, so in a buzzword-compliant modularity maturity model, you have the monolith, the composite, containers, discovery, and microservices, obviously. Okay, what does that mean? So in a monolith scenario, you're unaware of your dependencies, and you don't have to be because everything's together. Then you want to do a composite, you are actually being aware of infrastructural dependencies. So you know about things around you. You go one step up, and you don't care too much about infrastructural dependencies. Now you care about functional dependencies. And if you want to go one step up, you don't really want to care about dependencies, but what you care about is requirements. Because this is what actually you're solving. You have requirements which you fulfill. And then the final step is when you reach the point where you're able to adapt to a changing requirements and in your production environment. So if you look into what makes this happen these days, well, obviously monolith is Java, no big deal about it. Then you start probably using something like Maven. Then you're one step up. You no longer depend on the artifacts, but on identities, right? So you're already composing stuff. Okay, then probably you will be using something like Java Enterprise or Spring or CDI to actually introduce containers, to isolate yourself from the other world, and you kind of get a level 3. And that's pretty much as high as you can get with Java, unless you use OSGi, which gives you all the 5 layers. Okay, so before we step in and see how OSGi gives us these 5 layers, let's consider how we build software, how we think of building software. And one of the things that is, I think, wrong, but most common approach is to compare building software to building real-life products. So in the real world, if you want to build a product, something, where you start with materials, and then from those materials, you made some kind of intermediate, and then another intermediate, and then at the end of the day, combining those intermediates, you assemble a product. And this is how we think about software as well. So if you want to build this guy, a robot, what you would probably need is some tools. You would probably also need some software. You would probably need a computer to program the thing. You would probably need some parts like memory and disks and stuff like that. But for those to exist, they would also need some other tools. They have their own dependencies and so forth. And now, if you look carefully, you will realize this is a very oversimplified graph because it has no circular dependencies. And this is because we programmers are thought like circular dependencies are bad. And every time we draw a diagram, we make sure there are no circular dependencies, which is total nonsense, because in the real world scenario, you would have arrows pretty much between any of those, right? Let's keep it simple though. Okay, so this is how it looks like in a more general approach. So you have someone that offers you something, you use that something to build something else. This is how we refer to in a software world. We have artifacts that offers us functionality, and we use that functionality to actually build applications. That's pretty much what you do? Okay, no one says no, so I would assume. Okay, so now that we have this concept, let's see how we reach particular levels with OSGi. So I'll skip level 1 because it's obvious. You don't even need OSGi for that. So we'll start from level 2. And in level 2, you want to get yourself decoupled from the artifact. So you want an identity. You don't want to refer to a jar file, but you want to refer to a module. And for this, you have what is in OSGi known as a bundle symbolic name and bundle version. And a combination of those two will give your artifact a unique identity. So it doesn't really matter what is your jar file name, where it's located, where it's downloaded from. You don't care about the artifact. As long as you have an ID, as long as you have an identity, you decouple from that artifact, and you can always refer to it by identity, and then you can rely on the third-party tools to actually get the actual artifact just by knowing its identity. Okay, and this pretty much solves level 2. Which is essentially the same thing that you get if you're using Maven, except Maven is a third-party tool. And if you use Maven, you don't have anything at runtime that knows about artifact identity, whereas with OSGi, all this information is available for you at runtime, so you can inspect, introspect, figure out what artifacts come from where, and so forth. So now your application is actually aware of the components and their identities. So that's level 2. Okay, so let's move to level 3. Now, that's not too good. You want to actually get yourself decoupled from that identity because you start to having a dependencies from another things. And what historically people tend to do is to express explicit dependencies. Oh, my module wants that other module. And in OSGi, there is actually a header that you put in your manifest files that says require bundle, and you refer to another module, which is totally the wrong thing to do. Because you don't actually depend on another entity. What you depend on is the things that that entity offers you, right? If you want to buy a washing machine, right? You don't depend on a particular producer. You want a washing machine. You don't say, well, I now need pick a brand name, right? So that's the wrong way to do it. That's why OSGi gave up on this. And what is now exist in OSGi is the export package declarative on one side, which basically defines that if something, some artifact, provides you with a functionality. So in the case of this foo, it would say that foo offers power plugs, and it exports two different things: the standard power plugs and a power plug shop. So now, if you want to deal with power plugs, if you want to buy a power plug, then you can get power plug, a standard power plug, from anyone, not only foo, but anyone who offers you power plugs. Right? It happens to be that there is a full shop that offers you power plugs, but you can get that from pretty much anyone else. So this is how you decouple yourself from that particular identity, and you state that you actually don't want to depend on foo, but you want to depend on being able to get a power plug from somewhere. Okay? Now the flip side of that is the consumer, it's you. Now you want to also express what you need, right? And in OSGi, you have the import package from that purpose. So now you're saying, okay, for my functionality to work, I need a power plug. So you would put something like this. Import package, standard power plugs, from version 1 to version 2. Now notice that not only the identity in the sense of a name, but also the identity in the sense of a name and version. So we could say, oh, by the way, my software does not work with that new version of your package. It only works with the old version. Or you can have different pieces of your software that works with different versions. And when you talk about OSGi, and when you say to people OSGi, a lot of guys, oh, OSGi, that is the thing that you can have multiple versions of the same jar file. Yeah, but that is a side effect. That is to allow you to be able to design applications properly. That's not the main purpose of OSGi. OSGi wasn't invented so that you can have multiple versions. It's just a very essential thing for you to be able to design properly. Okay? And so now you can see here that this application also says that it probably would use power plugs shop from foo, but you could also use a power plug shop from someone else. Because you could have multiple other guys providing you power plugs. As long as you have a standard power plug, you're okay, you're good to go. So this brings you to the world where you are explicitly stating your requirements in a like functional, but not really infrastructural way. Okay? So this gives you like level 3. Now, if you think about it, it's still requirements. It's still you require something, you require a power plug. But if you think about it, you don't really need a power plug for your something to work. What you really need is to be able to plug that thing into a power source. What if there is another mean of plugging the thing into a power source apart from a power plug? Okay? This is where we start decoupling from implementations. When I say, I don't care, I want this thing to be connected to the power source one way or another. So you now, instead of requiring a power plug, you're stating a requirement. I need to connect to power outlet. That's it. That's my requirement. Whoever can do it, just go and do it. And now some other guy will say, oh, I can connect that device to the power outlet. One way, I can, just cut the wire and, stick it in, or I can use a power plug, or I can use, a new device that no one has ever heard of. It doesn't matter, as long as you can connect yourself. So this is the level where you start talking about requirements and not dependencies. You express what is really that you need, and not who you depend on. Okay? So how you do that in OSGi? You do that with a framework known as the requirements and capabilities. So this is your bundle, and it says it requires 2 capabilities. One is power supply, so you need to have the power supply somewhere, somehow. And that power supply has parameters. So it has to be between 110 and 230 voltage. Okay, so that is your requirement. You need to have that. And you need to have an electrician or someone that is capable of plugging your stuff in that thing, one way or another. And for that, you will say, well, this thing will have I don't want to pay more than 50 something for that, and I want this electrician to be certified. This is not different from anything that you do in the real world. You define your expectations and requirements and says, okay, those are my conditions. Will they be met? Now you run that into obviously when you define them, they're not met. You're looking for someone to fulfill them. So when you run that in the OSGi container, you can actually configure your container to say what is the environment. And let's say a container is configured in this way. It says it has a power supply with a voltage which is of type long equals 220. Now automatically, one of your requirements is fulfilled by the framework itself. That's okay, but you still need someone to be able to plug you in. So as soon as another bundle or another module or another plugin shows up with a header of provide capability that says, I provide the electrician capability, and my price is 10 something, and yes, I'm certified. Now, that is a capability that fulfills your other requirement. So in that very moment, your application can now run because everything it needs is met. And you didn't know, you can expect and use the APIs to figure out who fulfilled your requirements. But it's not important. It's not important if that was this jar file or that jar file or something else. All you know is that someone is capable to do what you expect to be done. And that's all you care about. So now we're not talking about dependencies anymore, but we're talking about fulfilling requirements. And this actually gives you level 4. Now, that's all fine, but it's kind of a static. It's kind of like, oh, we start things and we look for it. And what if things change? Like, so all of those in OSGi can change dynamically. At any time, a provider can go away. And that's totally fine. Your electrician, if you get an electrician to do some work at home, he may disappear the next day or next hour. What do? You don't say, oh, because I called the electrician, I have it for granted he will be here until the job is done. That doesn't work that way. And it makes totally no sense to work that way in an application world as well. Things can come and go. It's your responsibility to know what to do when things like this happen. Okay? And OSGi helps you a lot with that. It will tell you, okay, this happened. The effort, though, is on you to be prepared to deal with things like that. And this is how writing OSGi applications differs from writing regular Java applications. Because writing regular Java applications, you take things for granted. Say, okay, that's in my class path. It's never going to go away. No, it can. It can at any time. And it's your responsibility to know what should happen if that thing goes away. And it's your responsibility to know what should happen if that thing comes back. Right? Whether you want to accept it again, or you already wired to something else, or you use priorities, it's up to you to decide. Now, that is more on an infrastructural level. Now, we need to shift one level up to actually use services. Not just use the electrician, but actually use his skills, so to say. So, for this purpose, what we have in OSGi is known as a service registry. And basically every time, every single mature application, OSGi application, makes a heavy usage of a service registry. This is the place where you register yourself, your bundles, your providers will register themselves and tell what they can do. And much like in the real world, how you tell people what you can do? We use contracts. Whether those contracts are formal or informal, if you think about it, what is the word electrician? It implies that someone is capable of doing certain things. This is a kind of an unwritten contract. If someone is an electrician, you expect him to be able to do a certain amount of things. If someone is a doctor, you expect him to be able to do a certain amount of other things. So this is how we deal in the real world, by contracts. Sometimes those contracts are more formal. We'll write it down, we'll put conditions, what's going to happen if it's not fulfilled, and so forth. Most of the time, those are just verbal contracts that we kind of trust each other. So let me show you a diagram of a OSGi service registry. So in here, down there, you have 3 modules. And the first one is providing the white arrow, is providing a contract. A contract in Java world is nothing more than an interface. And that's exactly what interfaces are for. They define what can be done. They don't implement how. They don't say how this thing will be done, but they strictly specify what things whoever is the implementer of that interface should be capable of doing. So then you provide an interface as your contract, and that's it. That's all this bundle does. Or actually not. It also provides a, let's say, this other arrow from the same bundle that says register. It registers a service. It says this is the implementation of that contract. So I'm not only defining the contract, but I also have someone who can actually fulfill that contract. So they can do something. But there is another bundle out there that can say, well, guess what? I also have a service that also fulfills that contract. That's okay. You can have more than one electrician in the world. No big deal with that. So you could essentially have multiple, like tens, hundreds, thousands services that implement the same contract. It's totally fine. It's up to you as a consumer to choose which one you want to work with. Okay, so now this is the consumer guy, and he basically gets a reference from the service registry to a service that does the work. Now, the question is, how? As a consumer in the real world, what you could do is just open a phone book and do this guy, right? And OSGi world is telling OSGi registry, just give me an implementation. I don't care. Whoever who implements that, I'm totally fine to work with. Or you can say OSGi, oh, no. Give me the list of all of the guys that are implementing this interface, and I'll use my own logic or algorithm or whatever to figure out who I will work with. Oh, and by the way, notify me if that list changes. So if you realize this guy is gone or a new is coming, you just tell me, and I'll make my own decisions which one I want to work with at a given point of time. Or you can provide an OSGi registry request with parameters and say, well, by the way, give me a list of all providers, but only those who match my criteria. And my criteria are whatever they are. Okay? And that gives you the flexibility to choose who you want to work with without even having to know that such bundles exist or don't exist or who they were created by and so forth. And so this seems to be very clear. I mean, when I explain this to people, they kind of like, oh, yeah, that I understand, makes sense. And then they start implementing things in a little bit strange ways. And to make it more stranger, even the OSGi guys themselves implemented in a little bit strange ways when they first started to implement a HTTP service. So for HTTP service, that's pretty much what you know from Tomcat, Jetty, you name it. That's just HTTP server. You have an HTTP service, which is your contract. What is an HTTP service? What it's supposed to be doing? And then you have a bunch of implementations. Like this guy in the middle could be Tomcat, or could be Jetty, or could be any other web server. It will just register itself and say, oh, I do implement HTTP service. I am an HTTP service. I know how to do things. I know how to serve servlets. That's totally fine up until the moment when you start registering, when you start deploying servlets. Now, what is it that you do traditionally without OSGi? You throw a WAR file at Tomcat or Jetty or something. The Tomcat server or Jetty or whichever server will figure out where is your servlet and will register it with itself. That's why you provide descriptors, so that it can register with the HTTP server. Now, they implemented the same thing, basically saying, now in our servlets, we'll get a reference for the HTTP service, and once we have the reference for the HTTP service, we'll register ourselves with it. So using a native call down here. So if that's Tomcat, we'll call some Tomcat functionality to register our stuff with it. That works just fine. Can you see any issues with that approach? Anyone? Okay. Tomcat decides to go home. He's tired. He doesn't want to serve anymore. and he goes away. What happens to our servlets? Well, nothing. Server's not there, they don't care. Nothing works, but no big deal. Oh, but Tomcat goes 3 steps inside. Oh, now that's not nice. Let me go back, actually, and serve those requests. Now, Tomcat's back. What happens to our servlets? Nothing. They're totally unaware of that fact. They're not registered with anyone else. They're not registered with this Tomcat because he went away. So now we have a server that actually serves nothing. And we have servlets that are not served by anyone. And it's totally fine. Now, how you handle this situation? Well, you introduce listeners in the servlets. And you say, oh, by the way, notify me if that server goes away. And when it comes back, tell me so I can re-register. Which is totally the wrong thing to do. Because what you should do is you should avoid direct communications between modules and having modules being aware of each other by any other way but the service registry. So if you switch things around, don't register the server, register the servlets. So now you have a HTTP servlet contract which defines what is a servlet. And now you register your servlets with that. Then that's all you have to do from a servlet developer perspective. Just register your servlets, good to go. Now, when a HTTP service shows up, whether that's Tomcat or Jetty or something, they can go to the service registry and say, give me all the servlets. And inspect the parameters of those servlets to figure out at what context path they want to be served. And they can be served. Now then you have one thing that monitors everything. If servlets goes away and shows up, they will just refresh themselves. If they go away and show up, they will reread the information from a service registry. So you have a fully working dynamic at runtime implementation of an HTTP server that is totally unaware of what other plugins are running in the system. They are just aware of the functionalities that are in the system. This in OSGi is known as a whiteboard pattern. Every time you start reading about OSGi, you will hear the word whiteboard pattern. This is basically what it refers to, is get to the situation where you don't have a direct dependencies between your modules. Your modules are totally unaware of each other. It's the environment that provides information. So how you deal with services? If you want to really do it the hard way, this is how you do it manually. When you start a bundle, when you start a module, you have something that is called a bundle activator. It's essentially a main class for OSGi. Like when you run a Java app, the main runs. When you run an OSGi module, this thing runs. And it has two methods, start and stop. So in a start, you would normally get your service, create an instance of it, and then register it with 3 things. The contract, the actual implementation, and the properties. That's all you need to do. You just register it, and you're good to go. Once your bundle is stopped, you need to remember to unregister that service, and that's pretty much it. On the flip side, if you want to use a service, you use what's known as a bundle context to actually find a service reference. Once you have a service reference, and this is what you keep around, you can use that reference to actually get the real service, use it, and once you're done using it, you need to what's unfortunately named unget the service. It's kind of weird, but that's what the name of the method is. So basically you're saying, I'm done with that service. So the OSGi knows that no one else uses it anymore. Okay, now this is how OSGi looked 10 years ago. And this is one of the things that made a lot of people turn their backs to OSGi, because this is good if you do static programming. This is no good if things come and go at any time. Because if you look at the previous slide, by the time you get a reference to a service, and by the time you use that reference to actually get the real service, that service could be gone. you could have a reference to a non-existing thing. Okay? So, people start doing a lot of try-catch and a lot of crazy things. OSGi came up with what's known as a service tracker. And then everyone starts using service tracker, and these days if you want to use low-level, that's what you should be using, a service known as a service tracker that does this for you. But over the years, the process got highly oversimplified by introducing a component frameworks. And the component frameworks that I will introduce today to you is known as declarative services. It's part of the OSGi specs, so it's not a proprietary framework. You can also sometimes hear to refer to it as a service component runtime or SCR. SCR is actually the module that you need to have installed in your runtime to actually make all these things work. But essentially, this does the exact same thing as you saw in the code, but in a much nicer way. So you declare your components with an XML file. Now I see faces saying, and then how is the XML better? Well, agree, it's not. But the good news is you don't have to write it yourself. But first thing first, you need an XML which declares your components, where the methods are, and so forth. And then you have in your manifest file something that's known as a service component that refers to those XML files and says, okay, here is my component, go read the XML and deal with it. Then you have annotations inside your classes that actually do the thing for you, which is to generate the XML. Now, this is an add component annotation, and in here you will see that you have a bunch of things. You could have a configuration ID, whether it's enabled, whether it's immediate, what's the name, properties. You can put pretty much everything in a component. One thing to remember, this is processed at compile time. You're never ever going to see that annotation at runtime. This is used by compile time tools to generate the XML that you saw on a previous slide. There are also three other annotations like activate, deactivate, and modified, which defines which method in your class needs to be called when something like this happens, like your service is activated or deactivated or changed. The flip side of that, consuming a service, is at reference annotation. And in here it gets a little bit more interesting, because in here you can specify like the cardinality, whether that is a mandatory dependency or not, or an optional one. You will also say whether it's static or dynamic, or you would say whether it's a multiple, so you want a list or just want once. And also you have what's known as a target in here, which is where you provide your criteria. So in this particular case, I say, give me every single log service for which the property vendor.name equals Liferay. So I don't care for just any log service, but just those created by Liferay. Okay, and then obviously this is an LDAP-like query, so you can do a lot more complicated things. And the OSGi registry is responsible for giving you exactly those components that you asked for. That's pretty much what brings you to level 5, which is a fully dynamic system, where at runtime things change and they react to those changes. And it's very funny because if you go to industry conferences, especially Java-related, you will see that every single conference there is a talk about reactive programming, which seems to be the newest trend. Like everyone's talking about reactive programming, and like reactive programming is like 15 years old. It's just hard. It just requires you to start thinking in another way. And why? Because it's all about modularity, which is all about not knowing. A lot of people asking us questions like, hey, why did you choose OSGi for Liferay? Because OSGi in Java world is the ultimate solution for dealing with situations where you don't know. And we don't know. We build a generic purpose platform. We give this platform to you. It's 100 and whatever people in that room. And when you start using Liferay, you will be using it in 100 and so many different ways. There's no way for us to know how you will use it and what you will want it to do. And if we scale like worldwide, it gets even more complicated. So we reached the maximum of what portlet specs could do for us. And so we needed something that will allow us to be flexible, to allow us to actually give you the blocks that you can compose in any way you wish. And why are we talking about OSGi? Because we want to encourage you to do the same for your projects. I've been working with other companies before, building projects for end customers, and it always is the case that when you start your project, you're pretty confident you know the requirements. And when you're about to end your project, you're totally not confident you know the requirements because they keep changing all the time. Okay, if this happens to you, this is where OSGi will help you, because it will force you to think to admit that there are things that you don't know. And that's totally fine. It's totally fine to not know some things while you develop. But that enforces you to do optimizations for predictability. So now you think, okay, what if that happens? How do I react to that? And when you start thinking in that way, you're thinking about predictability. This is where you achieve application agility. And probably if you're in other management, more soft talks, you'll hear people talking about agile all over the place. And we do use agile for managing companies, but we refuse to use agile in our own applications. So if you ask me, the time has come to actually build an agile application, and applications that can adapt to changing requirements and to admit the fact that requirements change, and we are okay with that, and we can deal with that. And that's, according to me, how applications should be built. And this is, I think, what Liferay, with OSGi in it, and heavily based on OSGi, gives you. That's it from me for today. I think we have thank you for attending, not that you had any other choice. If you have questions, I'll try to answer them in the next, 2 minutes? Questions? Sure. Oh, there is one.
Hi.
Hey.
I'm wondering if there is no security breach in that thing, because if I say that I'm an electrician and I'm certified, but I'm not.
Oh, so the question is, what do you do in real life?
Yeah, but in real life you will see the electrician doing things. You will probably say that it will be the same.
I can go to your house claiming I'm an electrician. It's up to you to decide how much you trust me. You can say, I trust you. Or you can say, no, show me a proof. Show me your ID, show me your whatever. In OSGi, you can do the same. You can say, I trust the service saying it does what it does. Or you can say, no, I'm just going to work with a signed services, signed jar files, or something else. It's a different layer. It's a layer of trust. And you have to deal with that in any application, whether it's OSGi or not OSGi. It's up to you to decide who you trust and for what reason.
So it forces us to put in place all these verifications. Because if I want to hack the server, just pushing an OSGi application on the web app, a new one,
right,
and then it's going to deploy, and maybe it's going to switch to that one.
Right. So the thing is, the question that you want to ask yourself is, what's the worst thing that can happen? Right? If it's for example, if you take Liferay, you can provide your own user service and just essentially throw our user service away and provide your own implementation of that, or just remove it, as a matter of fact. You break in your own system. If you want to do that, fine with me. Now, if we were to do hosted solutions, we put Liferay somewhere and let other people deploy their applications, that won't be the case. We would do what is needed to ensure that everything that gets deployed there is actually secure in whatever secure mean for that particular environment. But that has nothing to do with Liferay. We would have to do that with portlets, with servlets, with pretty much anything else. Whether that's going to be standard Java security or something else. There are a bunch of technologies that provides you tools to do things like that. But it's basically not really related to how you design your app, but how you, what level of trust you want to apply to it.
Anybody else?
All right. I'll be around for the lunch, and I'll be back on stage after lunch. So feel free to find me and argue with me or just ask questions. Thank you again.